Hello, my name is Michael Edmund, and this is my research activity three. I'm going to share my screen. Alrighty, so in my recording, I will talk about my assumptions, how they were tested, the um, my analysis of the assumptions, and then the actual test that I conducted. So first, I want to start off with the histogram. Now, the histogram is how I'm testing my assumption of normal distribution. All right, so to do that, what I first did was I created my bins, which are right here. So they're preset. So those are my bins. Then I will go to, hold on, I gotta move video around a lot. So I will go to data analysis. I will click histogram. I'll press OK. Now it says input range. So I will click that. And as you see, this lights up because this is the information I will put, which are the grades, which are the continuous, excuse me. Come back to my histogram, then I will go to the bin range. I will click this, it brings me back to the Excel sheet. And as you see, it already highlights my bins right here. Come back up here. All right. Then I will go to my output range. So pretty much where am I going to put the chart at? So I will click this, and it will take me back to my Excel sheet. And I would, if I was going to create a different one, I will put it right here. I'll just click a spot, come back to the histogram information, and then I will check chart output. So with that, it gave me this chart right here. So with the histogram, what we will look for is the curves, bell curve. It'll go up like that. So with my data not going in the bell curve like it should, this tells me that there is no normal distribution. Excuse me, no normal distribution um, in my information. So then, what I would do next, I would then test the linear relationship. With that, I use the scatter plot. So what I do is I will come right here. All right, so scatter plot. So as you see, when I click my scatter plot, these two columns lit up. So it was my group one and my group two. Now, just making sure that we understand what group one and group two is. Group one is my in-person kids. Group two are my virtual students. So this will light up, excuse me. And then I would then come up here to insert. I will click scatter plot, and then I will click the actual scatter plot for itself. And then it will provide you with this chart right here. Now, with a scatter plot, what you have to keep in mind is that you're looking for a positive relationship or a negative relationship. And you also can have no relationship. Positive relationship starts from the bottom corner of the left-hand side and goes up to the right, the top right. And then a negative relationship starts from the top left and goes down to the bottom right. And then no relationship is all over the place. Now, what I did was I inserted the trend line just so we could see how close the data was to the trend. And with this, you see that there was some data that was close to it. But what this was just to see how close the data was to the trend. So this is the trend line. So that's what I inserted into the chart. But overall, the scatter plot is showing if there's any linear relationship in the data. And this is proving that there's no linear relationship because of my information is going all over the place. All right. So then next, what I then tested was my assumption for the box plot. And let me make sure I show you. So these are my assumptions, and this is what I'm looking at right here. All right, so take that down. So the box plot really pretty much tests if there's any outliers in my data. Now this one was really, really tricky. Like it was really difficult. So what I did was, I actually had to highlight that because I put so much on this page. So what I did was I had to look at the minimum value. So if you click right here, I used the minimum value formula. So what that is was it just took the data from box A, excuse me, from cell A25 to cell A31. So that's this information right here. So it took that and it gave me 27 as my minimum value. And I pretty much did the same thing for group two. Now for the first quartile, I used another formula. And once again, it took my information from cell box A25 to A31. And as you see up at the top, it used that information, but it also used a one because it's the first quartile. Once I calculated that, it gave me 69, and I did the same thing for group two. All right, then I go to median value. Once again, gave me the same formula. Use the same information from A25 to A31. And then it has a two up here now because this is the quartile two. I calculate it gives me 73, and I do the same thing for group two. Group three, same thing, same formula, use the same information, but instead now I'm using a three for the third quartile. Calculated gives me 87, and I did the same information for for group two. All right, so then I'm looking at the maximum value. So if I click that, it actually has a value, a formula for its own formula. So once again, it uses the same information from A25 to A31. Calculated, it gives me 91, and I did the same thing with group two. Now that's not the information that I use for the box plot. So what I did do, so down here, so this part right here is the information I use for the box plot. So then my minimum value for group one and group two, I just copied it from here. But from here, with the medium and the first, what it is doing now is taking a difference. So it's using another formula, but it's just subtracting. So it's taking a difference from the medium and the first quartile, from the third and the median, and then from the maximum and the third as well. So it's just pretty much taking all that information, and it's just doing taking the differences. So from here, that's when I go to I would go to insert, and then I could click this, click the icon that looks like the bar graphs, and I'll click this second one that's under 2D column. I'll click this one right here. Now I gave a lot of information because a lot of things is highlighted, but with a lot of editing and modifying, this is how I end up with my box plot. Once again, this is real tricky, and it took a lot of watching videos and reading to try to get it to this point. So I really hope I did it right. But pretty much what this is proving is that there are no outliers in my information. Pretty much, there's no outliers in my data. And then my last assumption was homogeneity of variance, and I would use the Levene's test. But instead of using the Levene's test, what I did was I used the ANOVA. And pretty much using the ANOVA gives the same P and F value. Well, it gives me a P and an F value. Excuse me. And what I'm looking for is for the P value and the F value to be the same. And since this information right here is not highlighted, or excuse me, since this information right here is not the same, then that would tell me that there's no homogeneity of variance in my data. I highlighted it honestly just to kind of make sure that I knew where I was going. Because once again, I put a lot of information on here and I wanted to make sure that I could address everything. So that's why that's highlighted. But this information should be the same. But since it's not, that means that there's no homogeneity of variance in my data. So now I can run my independent samples t-test. Because what I did just prove now, I just showed my assumptions. And the only one that was met was that my variables are continuous and that there were no outliers in my information. or in my data, excuse me. So what I'm doing now for the independent samples t-test, so then I'm going to come back up here, click data. I'm gonna move this down. I'm gonna click data analysis, and then I'm gonna go to t-test, assuming unequal variances. And then I will press OK. And then with that information, it will calculate, or excuse me, it will calculate. It will calculate this chart right here. Now, what I end up having to do, I had to start typing in my group 2, which is my virtual students. I had to start typing in that information first before I did group 1, which was the in-person students. My information was all over the place, so I just switched them. And also, honestly, because the variance was high for group 2, so I just switched it. Hope I did that correct. Now, with this information, what I'm trying to prove is that, excuse me, is that since my p-value right here is not less, is not less than my alpha value, which is 0.05, is actually more, that means that I can accept my null hypothesis. So that's pretty much what what I had to do with the independent samples t-test, was to test to see if I could reject or accept the null hypothesis. And since I did not have to, excuse me, and since I did not get a value that was less than the alpha, which was 0.05, that means that I could accept my null hypothesis. So that's what this information right here shows us. All right, so then I'm gonna go to pair samples t-test. All right, excuse me. All right, so once again, I'm doing a different test, but since my information was the same as far as my assumptions, I used the same. I use pretty much the same assumptions. So now I'll pull that up. So variables are continuous, which I proved that my normal distribution, histogram, and then my outlier, which is the box plot. So that's why you see that information. So once again, with the histogram, we were looking for the bell curve. And since the histogram did not give us a bell curve, it showed that it was no normal distribution amongst the data set. All right. And then for my box plot, once again, I took the information, went to data analysis, actually, I didn't do data analysis. Actually, went to insert, and I clicked my 3-bar graphs up here, and I clicked the second one with the 2D column, and that's what I did to get the box plot. Excuse me. Kind of had a brain fart right there. All right, but once again, I used the same information because the information was pretty much the same. I was just using a different test. So what I did do was the paired samples t-test. So for that, I will go to data, data analysis. Okay, so then I go to pair samples for means, and I'll click OK. Excuse me. All right. And then once again, I will get calculated information. All right, and then I'm going to look at the p-value once again, and my p-value is 0.1. Now, it has to be less than 0.05 in order to reject the null hypothesis. But since this is not lower than 0.05, which is the alpha, then I could once again accept my null hypothesis based on my paired samples t-test. Excuse me. And the point of the pair samples t-test, honestly, it's really to determine whether the mean difference between my data is significantly different. It's significantly different from 0, as well as under seeing if I would have to either accept or reject my null hypothesis. So this information right here with this, once again, this p-value being greater than the alpha, which is 0.05, this means that I can accept the null hypothesis. And this is pretty much the information, once again, that I still used. All right. So then I did the one-way ANOVA, which is the last test that I have to conduct. So with the one-way ANOVA, my assumptions pretty much the same. Testing for make sure the variables are continuous, normal distribution, and then homogeneity of variance. The point of the one-way analysis, just comparing the means and trying to see if my means are significantly different from one another or not. So once again, just to review the histogram, we know the bell curve, it does not show the bell curve. There's no normal distribution. The box plot proved that there were no outliers in my data set. My variables are continuous. My dependent variables are continuous. All right, and then my one-way ANOVA test. So what I would do is once again come up here to the top, click data analysis. Then I will go to ANOVA single factor. Press OK. All right, so my input range, I will click, and it's going to light up my information. Now, with this information, I first was using the one column, but it was not allowing me to do that. So I made them into 2 separate columns, and it took it like this. So that's what I did. All right, I made sure it was grouped by columns. The alpha was still 0.05. Output range is just pretty much a place to put the information. All right, so then if when I'm going to cancel that, it is going to bring up this chart right here. So sorry, I should have made this a little bit better. But this chart right here, and once again, looking at the p-value, the p-value once again is greater than my alpha. My alpha is 0.05. So with that, this is telling me that there are my means are not significantly different from one another. With the p-value being 0.2, my means are not significantly different from one another. So that's what this means. Now, I want to go back and make sure I showed the paired samples t-test, because I just realized that I actually didn't show you that part. So paired samples t-test, go to data analysis, click paired samples, press OK. So that's giving me that. So variable one range, click that. It's going to highlight the range of the data range that I'm using. As you can see, once again, it's going to the group 2 students, which are the virtual students. Click that. Go to variable 2 range. Click that. It's going to highlight the students that are in person, as you see right here. My hypothesized mean difference is 0, of course, and there's 0 for each one that I had to use that on. The alpha is 0.05. And then my output range, once again, will be a space that I could click to put the information. All right, then I'm going to cancel all that. And once again, the p-value being greater than the alpha, it told me that I could accept my null hypothesis for the paired samples t-test. All right. All right, so that is it. I'm going to stop sharing my information. All right. Well, I hope this was way better than the last research activity I did. I actually really tried to do this. I actually tried to make sure that I was being intentional on actually understanding what I was doing. So I definitely wanted to try to make up for the last activity that I turned into. So I really hope this is way better than last one I turned it to you. All right, and then I will see you later. Thank you for listening, and I can't wait for your feedback.